Alright, here we are using Ulises putting some more water in there. We have the dye. And we do have our flow right there. You can see that looks pretty good. Pretty laminar. We are filling up that right there. So we're going to be able to measure the flow rate. And so here is the dye going through. You can see it's going through pretty smoothly. It's racing through right now. You can see that darker bit right there. Racing through right there. Of course, giving us that beautiful flow that we have at the end. And so we are filling that up so we can get the flow rate and of course get the official numbers, but it looks pretty good. That flow looks amazing. You can barely even tell it's flowing, honestly. So, yeah. And you can see right there, that's a beautiful flow, don't you think, Uli?
I think so.
Perfect. So beautiful flow right there. We are getting that filled up. You can see it even comes out green, of course. But yeah, this is our lovely contraption. That's kind of what the water level we're at. In there, there's a small hole within that that medicine measure thing that we used. And here you go. Uli's putting in some more dye through the inside, actually, this time. And we'll be able to get another look at how that flow is going. You see it's going pretty smoothly, honestly. Just going through. Flow is still looking really great. We're still filling that up. That is a measured bucket, so of course I do know when to get it. And it is being timed, so that is a beautiful flow. Really pretty. Really pretty flow right there. And here Uli is about to insert some even more dye. Kind of at that start. I mean, we'll see it right here. Of course, it comes out a little bit turbulent at first, just due to the force that Uli puts in. He's a very strong guy, so we do see that flow kind of adapting into how the water is going. Once it regulates, you can see that tiny bit right there. It's going through it right now. Yeah, this is a great flow. I think we're very happy with the results of this laminar, and soon we'll be able to show you what the map looks like as soon as we get this that bucket filled, or that little plant filled, and we'll be able to show you next. After that, we'll be able to show you what turbulent flow looks like. So we're very excited. We'll take a small break.
So here we'll be finding the velocity and the Reynolds number for the laminar flow that we just looked at. So I've already found the flow rate, which we found from the volume over time. And here I already solved the velocity, which is the flow rate over the area, and we found it to be 1.84. And now we're just plugging it into the Reynolds number equation. And here we can see, plugging in all the values we have, we get a Reynolds number of around 1,468, which in fact means it's a laminar flow, which we showed in the video beforehand.
All right, so we did just show you what laminar looks like. And then here we're going to show you what turbulence looks like. And yeah, we're going to be doing that by putting a lot of water into there, having it all go crazy, putting the dye in. We do need to fill up that dye before we start. And yeah, it's all going to come out through here. We're going to unplug this, and we're going to see all the chaos that is caused once because of course this is going to be the turbulence one. So we already know kind of how much is going to go in, how much is going to come out. We kind of already have an idea as we've tested this multiple times. So we'll be able to show you that. We'll be able to get the flow rate and everything mathematically all gone through that. We do have our picture over there that has exact measurements and liters. And So yeah, we'll be showing you that as soon as Yuli gets this dye going through. And then I'm gonna grab the pitcher, put it on this tail end. We're gonna put it in the bucket so we can, and we'll adjust as needed once we get this dye going through. So here's our preparation of the dye. This one is a green dye.
Yep.
Yeah, so we'll take out this, put that in to the new hole. All right.
Now, you gotta pour the water.
Now you just gotta pour the water. All right, you can already see it's already coming out really clear. So we're about to pull the restraint, and we're about to see how strong this really is. You can already get an idea. Look, it's just going at it. The dye is going through. You can barely even see it. All right, so we just filled almost about 800 in less than a second. So we already know this is going to be a very turbulent water flow. You can kind of see now that the water's dying down. It's coming out. Pour the bucket a little bit closer, don't want to get all wet. But yeah, we are seeing a very turbulent flow here. If you want, let's well, we don't have any more water, but try one more time so you can kind of see.
And here we'll find the velocity, the flow rate, and the Reynolds number for our turbulent flow. So we can find the flow rate by calculating the volume over the time it took to fill, and we get that it's 5 times 10 to the negative 4. And now we can plug it into the other equation, so we can get V, which is the flow rate over the area, and by plugging in all the numbers we get that the velocity is around 0.248 meters per second. And now we can plug it into the Reynolds number equation with all our givens. So we have 998 times the velocity times the diameter of the tube all over its viscosity, and we get the number to be 19,814, which is turbulence.
All right, so this is going to be the second test. We're about to plug up some dye, and you're about to see how turbulent this flow really is.
Let me know when you want to let it go.
All right, 3, 2, 1, let go. So you can see it's going out really quickly. You can barely even see the dye going in. You can tell it's a very turbulent flow. It just goes straight out, straight back in. Water's not going out, but yeah, it's a very quick, very fast action. What used to take us minutes is we just filled up that bucket, and in less than 2 minutes. So you see that's a very turbulent flow again, and yeah, I think that concludes our video. Me and Ulises, where we kind of showed you the two differences of how laminar and turbulent flow looks like.